Welcome to Don's Manufactory. Why, of course, I am still down here working on stuff. This is the latest arrival. It belongs to a friend of mine. It's an Audient ASP880. So this one, it's another power supply problem. It's an old enough unit. I can just look down through the vents here, and the filter capacitors on the switch mode power supply are all expanded and swollen. That's where I'm going to start with this one. I'm not even going to tear into it yet. I'm just going to let it order some filter caps for it, and we'll proceed. Anyway, I've been getting some grief about why I'm fixing all this old gear. Like, what the heck difference does it make? You can buy a unit on eBay for $100, $200, whatever. Of course, there's no guarantee that's going to work. Or just throw it away and buy a new one. Well, number one, Ibanez SDR1000s, same thing as the Sony MUR-201. That stereo processing was revolutionary back in 1985, and for cost reasons they have not reproduced it. And the way that unit processes a stereo reverb signal, it allows you to manipulate sounds inside a 3D sound field, and that is almost impossible with other reverbs. Their algorithms just don't work that way. You can pan the dry signal inside the reverb, but you can't actually move the reverberated image around inside the 3D field. And that's why that unit is so valuable, at least to me, and why I want to fix it. Besides, why should it end up in the landfill? I'm on an electronic buzz now. I've got pieces of gear here that I need to fix, stuff of mine, and this one just came in because he's a friend of a friend, and they just happened to see my video of me fixing stuff. And so, yeah, this stuff can really snowball out of control. Anyway, so here's the next installment of Dawn at the Workbench. Another piece of gear has failed. I've been running through, checking everything. This is my Ibanez SDR1000. And it ran for about 10 minutes and then started making noise. There's two little relays. Started chattering. See, let me show you some. Whoop. And I looked it up on the schematic. There is a 5-volt reference that trips those relays. It also does the reset for the CPU. I believe what's going on is the reason it's aping out so much and the relays are chattering is because this capacitor right here has failed. So I'm going to remove it. I'll check it, because in the circuit it doesn't seem to be doing anything, but then the circuit can have a big influence on what's going on there. This is one of my favorite reverb boxes. Oh, we'll just see what happens here. I'll get this dang thing out. Okay, what's left I can get with the solder wick. A lot of power supply problems when gear sits around. The capacitors just give it up. Okay, let's see if it comes out now. Yep. Okay. 33 microfarads at 25 volts. Well, I don't know if I have one this small. 1.2 nanofarads. It's supposed to be 33 microfarads. So yeah, this capacitor is not working. Well, now I gotta see if I have that capacitor in my inventory. If I've never mentioned it before, one of my best friends, George, used to work for an electronics firm here in town. And when he was retiring, he went through the inventory of the firm and packaged me 10 of every part they had in inventory. So I'm talking resistors, transistors, diodes, capacitors. It was just amazing. And then he went into all the parts that were written off and just threw them in the box. So every written off part that they were no longer using in production, I ended up with all that too. So it's a whole bunch of brick resistors and all kinds of stuff that went back decades. So I've had this inventory for 30 years now, and I am still fixing stuff out of this inventory. Okay, enough of that. Let's get down to cases here. I'm looking for 33 microfarads and with a 25 volt breakdown. That's 4.7. So even if it's too big, you know, or it has a higher voltage rating or something, it's not a problem. Here's the capacitors I threw in here left over from my latest Supro repair. 47 at 35 volts. That's probably getting close.
It is appropriate to use a larger capacitor here because it's just a filter in a linear regulator.
47 at 25 volts. You know, I could get away with that. That's a 47 at 35 volts there. But that's an axial, and it'd be better if it was radial. I'm just going to put one of these in. This is a polarized cap. Instead of 33, it's 47 microfarads. So what I will have to do is do it like this. So you bend it over, stick it in the circuit like this, and this being the positive. See, it's marked negative. Yep. Okay, so then it would there's just enough room to get this in here.
Must follow the polarity marked on the circuit board or measure it if it's not marked.
And flip it over and we will solder it in and we'll see if I just got through fixing it. Oh man, it's just like having my favorite guitar or guitar amp not work.
For those of you that don't do any soldering, it's important to heat the work and then have the solder flow into the work rather than, you don't want to just daub the solder on the soldering gun and then try to stick it to the work, because that is going to be a cold solder joint that will never last if it even works.
It's still got a lot of ripple in it. See, let me show you some. Whoop. See, still going. Let's see if that extra filtering did anything at all. Let me see what it does. Nope, we're still error 9. There is still something wickedly weird about that power supply.
This is an isolated supply, ground and whatnot. That's why the scope shows ripple.
Okay.
Yeah, I'm chasing my tail here. That's why I have not figured it out yet.
Okay, let me show you this. I don't know if you'll be able to see this on the scope. Let me show you. When I turn this on, we have a real clean negative supply. See, it's got just a little bit of ripple. Real clean positive supply, a little bit of ripple. But then we get to this guy right here, and look at the ripple. So I replaced this capacitor right here, and that capacitor was toast, but something else is funky here. So what I'm doing here is testing the relay, the one that vibrates and makes noise. And it's showing a clean power supply on both sides. It's also showing 12 volts. And this thing, well, it might be 12 if it was better filtered.
This is painful to watch, but my future self already knows what's wrong, so hindsight is accurate.
I just wonder if these diodes are toast. One of them is. So it's making the ripple. Because it shouldn't be rippled that much. Well, no, it's not doing anything. It's not even giving me error 9. There's got to be some other sources of power here. I mean, now it's completely dead. The display doesn't even do anything. And it says meter drive. And there doesn't seem to be a lot of ripple there. 5 volts per division. So that is 12, 13 volts right there. And that's way up there at 5, 10, 15, 20. Hi, welcome to Don's Manufactory. Well, in the latest things electronic blowing up, it was my scope. A friend came over and asked me to look at his Volvo 1800 with a fuel injection problem, and I wanted to get it on the scope and check out the fuel injection pattern and the ignition system and everything. I took it apart, blew all the dust out, cleaned everything, all the dust, you know, it's been hanging out the whole time I was working on the Mustang, and cleaned it up and took all the connectors loose and put them back on to clean the connectors, and it just wouldn't come on. And so I had to diagnose his car the hard way. And the minute he drives off, I walk over, I hit this button, and sure enough, it's working. This is my life right now. Anyway, I like this scope. It runs off at 12 volts, so I can hook it onto the car and we can go drive it. Any anomalies that happen, like underload, higher RPM, I can just hook this up and look at everything all at the same time. Anyway, it's working now. I don't know what that means. I'll just keep going. Okay. Welcome to Don's Manufactory. Well, here I am at the bench again. The parts for the reverb should be showing up today, so hopefully I'll be getting that fixed. But last night I was running the gear just to make sure nothing's going to blow up, and sure enough, this delay line, it's a Roland SDE 1000. It was still working and it was delaying the signal, but the display went out. So while all the switches work, I can increase and decrease the time and do all of that, I can't see what I'm doing. And the display kind of flashes. I don't know if I can get it to do it for you here. I'll just try it. every now and then when you turn it off, the display will flash. So I know the display is good. And the furthest I got on diagnosing was using my scope probe here. It looks like I have data coming out of the CPU that's supposed to be interpreted by these two ICs and then amplified by these two to 20 volts, which drives the FIP display. These have 20 volts. They are putting 20 volts out, but the first thing is nothing's being multiplexed. I believe it's supposed to be a multiplex signal. I'm not getting proper signals out of these two ICs, and I don't know enough about it to know what the heck is wrong. Fortunately, Sun, I used to work at Sun, and they had used FIP displays on their SA power amps. So I'm going to go drag schematics out for that and try to determine from that what FIP displays need in order to operate. Because for right now, all of the power supply stuff works. Things that are ground are ground. The 20 volts is coming in. It's got 2 volts at these little filaments that run across here. But I'm not getting any illumination, and I just I don't understand.
Captain Obvious there, Don.
So who knows where the circuit went wrong, but unfortunately the service manual from Roland doesn't include, well, the wiring diagram for the display and all of that is there, but there's no explanation of circuit or test methodology for fixing the display. They have it real intensive instructions for how to sort out RAM problems and CPU problems on the board, but nothing about the display. So I'm just sort of left to figure it out on my own. Try to find a failed component. It could be anything. It could be a transistor or one of these ICs that's just dead. That's where I'm at. Gear is still blowing up and I'm still trying to get it fixed.
Well, working on this here, well, it's a digital delay line SDE1000 by Roland. Alrighty, so this thing, I've been troubleshooting for most of the day on this. It blew up this morning. And what I have finally gotten it down to is, it is the crystal. This is an 11 megahertz crystal that sets the clock for the CPU. It just quits. What I can do is take my solder gun and heat the terminals, and then it takes off working, and as soon as it cools off, it quits. But when it clicks on, then all the diodes and the display works and everything. So I think that's the only problem that I have, hopefully.
Well, hi. Yes, I'm working on the Sony SDR1000. So I just replaced the 5-volt regulators, and it still wouldn't work. However, you had a very odd thing that when I pushed right here like this, it would start working. And I thought maybe it was broken solder joints on the processor. Nope. Turned out to be broken solder joints on this power connection right here coming out of the power supply. So now that that is all done, ta-da! Isn't that great? Different programs, everything's working like it's supposed to. Got to get it back together and in the rack. Woohoo!
So looking in the top of this unit, the green arrows are pointing out these copper bus bars that they installed to help make the circuit board more rigid. They provide ground and power to different parts of the board. So it's imperative that all of the solder joints on these bus bars is 100%. See on the bottom here, I've got it circled where those bus bar tabs come through. And you can see they're soldered right into the circuitry. So without 100% connection there, the unit's not going to work right. And actually, these things are really susceptible to broken solder joints because that circuit board is attached only by its periphery, so heat and vibration makes the whole thing flex. While you are looking at this side of the circuit board, any solder joint that has even the hint of a ring around the joint, go ahead and touch it up because it's the beginning of a broken solder joint. I want to thank you for watching Don's Manufactory. I'll catch you later.